Hello everyone. In this video, we shall discuss about angles and their measurement. This topic will also serve as an introduction to trigonometry, which is the study of the measurement of triangles and circular functions. Circular functions will be studied in a separate set of videos. Now, what is an angle? An angle is formed by two rays emanating from a point or a vertex. So in this figure here, this point is our vertex, and observe that there are two rays emanating from this point. Now, the space in between these two rays is our angle. Now, there are several types of angles. An angle is said to be an acute angle if its measurement is between 0 degrees to 90 degrees. Now, it is a right angle if its measurement is exactly 90 degrees. And an angle is an obtuse angle if its measurement is between 90 degrees and 180 degrees. Now, if the angle is measured at exactly 180 degrees, then we call it a straight angle. And then angles measuring higher than 180 degrees and lesser than 360 degrees are called reflex angles. Now, in trigonometry, we focus on angles that are said to be in standard position. So, an angle theta in standard position on the Cartesian plane is an angle that has its vertex at the origin and its initial side along the positive x-axis. Now, there are two angles on your screens right now. So, the angle in the left side is in standard position and it's measured at 135 degrees. This is an angle in standard position because its vertex is at the origin and its initial side happens along the positive x-axis. Now, the angle is positive because it is measured in the counterclockwise direction. Now, this side here is what we call as the terminal side of the angle theta. Now, the angle at the right side is negative 60 degrees. It is negative because it is measured in the clockwise direction. And this angle is also in standard position because its vertex happens at the origin and its initial side is along the positive x-axis. Now, angles are measured in two ways. It can be measured in degree measurement or in radians measurement. A degree, usually denoted by this symbol, is a measurement of a plane angle in which one full rotation is 360 degrees. A full rotation is equal to 2 pi radians, and 1 degree is equivalent to pi over 180 radians. Now, the radian is the ratio between the arc length and radius of a circle. And 2 pi radians is approximately 6.283 radians. Now, in the following figure, we see a circle having a center point here, which is the C, and then having a radius of length R. Now, observe that whenever we have an angle alpha here, so this angle alpha intercepts a part of the circle, which is the arc, an arc in the circle of length R. So if we get the ratio of this arc length and the radius of the circle, we have R over R, which is equal to 1. So this means that alpha is equal to 1 radians, and it is because that the radians is the ratio between the arc length and the radius of a circle. Now, how do we convert angles in degree measurement to radian measurement? So in converting angles in degrees to radians, we multiply the given angle in degrees by pi over 180 degrees radians. So for example, let us convert the following angles into the radian measurement. So first one, we have 135 degrees. So we multiply this by pi over 180 degrees radians. So in this case, the degree unit of measurement will be cancelled out. So we will get 135 pi over 180. And in lowest terms, this 135 pi over 180 radians is equivalent to 3 pi over 4 radians. Now, second, we have negative 270 degrees. So we multiply this also by pi over 180 degrees radians. And this will give us negative 270 pi over 180 radians. And in lowest terms, this is negative 3 pi over 2 radians. Another example would be 48 degrees. So just like in the previous two items, we multiply this by pi over 180 radians. So this will give us 48 pi over 180 radians, which is equivalent to 4 pi over 15 radians. And finally, 300 degrees multiplied by pi over 180 degrees radians. This will give us 300 pi over 180 radians. So this is in lowest terms, this will be equal to 5 pi over 3 radians. Now, for angles given in the radian measurement, but to convert it in the degree measurement, this time we multiply the radian measurement by 180 degrees over pi radians. So let's have examples before this part. So let's convert the following angles to degree measurement. So 7 pi over 15 radians will be multiplied by 180 degrees over pi radians. So this means that pi radians will be cancelled out here. So we have 7 times 180 divided by 15. Now, if we divide 180 by 15, that's going to be 12. And then multiply it by 7, so that's going to be 84 degrees. Now, second, negative 13 pi over 12 multiplied by 180 degrees over pi radians. So this will be 180 degrees divided by 12, which is 15. And then we multiply it by negative 13 pi. So that's going to be negative 195 degrees. And then for 7 pi over 6, we multiply this by 180 degrees over pi radians. So 180 degrees divided by 6 is 30 degrees times 7 pi, times 7, which is 210 degrees. And then finally, negative 5 pi over 2 multiplied by 180 degrees over pi radians. So this is going to be 180 divided by 2, which is 90, multiplied by negative 5 pi, which is negative, negative pi 5, which is negative 450 degrees. Okay, next, let's have the concept of coterminal angles. Now, we say that two angles are coterminal if they have the same terminal sides. But note that these two angles must be in standard position, which means that their initial sides must happen on the positive x-axis. Now, in degree measurement, to get a coterminal angle from a given angle theta, we either add or subtract multiples of 360 degrees to or from the given angle theta. So it's like um, you're adding 360 degrees continuously until you get an angle that will be coterminal with the original angle, or you're going to subtract 360 degrees from the given angle theta. And then in radian measurement, that to get a coterminal angle from a given angle theta, we add or subtract multiples of 2 pi to or from the given angle theta. So let's try the following. Find two angles that are coterminal with 52 degrees. So actually, there are a lot of angles that are coterminal with 52 degrees because we can get an angle that will be coterminal with this by adding 360 degrees. And then we can also have another coterminal angle wherein we add 2 times 360 degrees. Or sometimes we can also have a coterminal angle wherein we're going to subtract 3 times 360 degrees. So the formula for getting the angles that are coterminal with 52 degrees would be 52 degrees plus k times 360 degrees, where k is any integer. So k could be uh, positive or negative. So if k is equal to 1, then a coterminal angle would be 52 degrees plus 1 times 360 degrees, and we have 412 degrees. And then if k is equal to negative 2, then a coterminal angle would be 52 degrees plus negative 2 times 360 degrees. Now we can also write this as 52 degrees minus 2 times 360 degrees, and that will give us negative 668 degrees. Now for radian measurement, now let's find two angles that are coterminal with 4 pi over 3. So the formula here would be 4 pi over 3 plus 2 times k times pi. So again, whenever we have or we are in the radian measurement, we add or subtract multiples of 2 pi. So here k is also any integer. Okay, so if we have k is equal to 2, then a coterminal angle would be 4 pi over 3 plus 2 times the value of k, which is 2, times pi. So that's going to be 4 pi over 3 plus 4 pi. So combining these two, we get 3 as the LCD. 3 divided by 3 is 1 times 4 pi is 4 pi. And then 3 multiplied by 4 pi here is 12 pi. So 4 pi plus 12 pi is 16 pi. So which means that 16 pi over 3 is a coterminal angle of 4 pi over 3. Now, another coterminal angle would be whenever k is equal to negative 3, then a coterminal angle would be 4 pi over 3 plus 2 times negative 3, which is the value of k, times pi. So this is the same thing as 4 pi over 3. And then 2 times negative 3 here is minus 6 pi. So combining these two, again, 3 is the LCD. So 3 over 3 is 1 times 4 pi is 4 pi. And then 3 times negative 6 pi will be negative 18 pi. So simplifying the numerator, 4 pi minus 18 pi is negative 14 pi, and then we have over 3. So this one is another coterminal angle to 4 pi over 3. Okay, now if we want to get a coterminal angle that will be inside the interval from 0 degrees up to 360 degrees, then we should be getting a value of k. So that means if the angle is more than 360 degrees, we're going to continuously subtract 360 degrees from it until we find an angle that is inside the interval. But here, we can actually divide 1,233 by 360 degrees, and that's going to be approximately 3.4. So we're going to round that down to k equals 3. So round down 3.4 to 3. So this means that we're going to subtract we're going to subtract 3 times 360 degrees from 1,233 degrees. So this is actually a multiple of 360 degrees. So 1,233 degrees minus 3 times 360 degrees is simplified as 153 degrees. And observe that this angle is inside the given interval from 0 degrees to 360 degrees. Now, another example would be, let's say we have an angle negative 750 degrees and we want to find an angle coterminal to this angle, but the coterminal angle must be inside again 0 degrees to 360 degrees. Now, if the angle is negative, then we should add something to negative 750 degrees so that we can have an angle coinciding this interval. So just like in the previous example, we're going to divide negative 750 degrees by 360 degrees. and that's approximately negative 2.1. So we're going to round that down to negative 3. So round negative 2.1 down to negative 3. So a coterminal angle would be negative 750 degrees minus negative 3 times 360 degrees. But observe here that this negative here and this negative here now will become positive. So it is negative 750 degrees plus 3 times 360 degrees. And that will be simplified into 330 degrees. Okay, now for radian measurement, so let's find an angle theta in the interval from 0 up to 2 pi that is coterminal with 35 pi over 4. In the radian measurement, the process is quite different from the degree measurement. So here, we will be dividing the coefficient of pi. So 35 over 4 is approximately or is equal to 8.75. So this angle is equal to 8.75 pi. So this 8.75 pi is actually higher than 2 pi. So this means that we're going to subtract something from this angle that will be inside this interval. Now the term that we're going to subtract from 8.75 pi must be multiples of 2 pi. So since we have 8.75 pi here, we are going to subtract 8 pi because that's the highest multiple of 2 pi that is less than 8.75 pi. So which means we're going to subtract 8 pi and 35 pi over 4 minus 8 pi. Combining these two, LCD will be 4. And then we have 4 over 4 is 1 multiplied to 35 pi. So that's 35 pi. And then minus 4 multiplied to 8 pi is 32 pi. And then the LCD is over 4. So 35 pi minus 32 pi is 3 pi over 4. So this angle here, 3 pi over 4, is actually in between 0 to 2 pi because 3/4 is 0.75 and that is between 0 and 2. Now another example is what if we have 16 pi over 3? So dividing 16 by 3, that's approximately 5.3. So this angle is equivalent or is approximately 5.3 pi. So the highest multiple of 2 pi that is lesser than 5.3 pi is 4 pi. We cannot subtract 5 pi because 5 pi is not a multiple of 2 pi. So we have to subtract 4 pi only. So 5.3 pi minus 4 pi, that's approximately 1.3 pi. And it's going to be 16 pi over 3 minus 4 pi. And combining these two, that will give us 4 pi over 3. And 4 pi over 3 is inside this interval because 4 over 3 is 1 and 1/3. And that's between 0 and 2. Now, if the angle is negative, then we have to add multiples of 2 pi. So if we divide negative 13 by 3, that is approximately negative 4.3. So we have here negative 4.3 pi. So we have to add a multiple of 2 pi. So what we're going to do here is we're going to get this 4.3, ignoring the negative sign. And then we get the lowest multiple of 2 pi that is higher than 4.3, which is 6. So that means we need to add 6 pi to this angle. So negative 13 pi over 3 added to 6 pi. So that's going to be negative 13 pi. And then 3 times 6 pi is 18 pi. So negative 13 pi plus 18 pi is 5 pi over 3. Now 5 over 3 is 1 and 2/3, which is actually between 0 and 2. Okay, so this is just the same slide. All right, so now an angle theta in standard position belongs to the quadrant that contains its terminal side. So if we have the Cartesian plane or the coordinate system, this region is quadrant number 1. This region is quadrant 2. And then we have quadrant 3. And then we have quadrant 4. Now, in degree measurement, if the angles are measured between 0 to 90 degrees, that angle must be in quadrant 1. So for example, 45 degrees is between 0 and 90 degrees. So 45 degrees must be in the first quadrant. Now in radian measurement, the angles measuring between 0 and pi over 2 are also in the first quadrant. Now pi over 4 is an example of an angle in radian measurement that is in quadrant number 1 because 1/4 here is between 0 and 1/2. Okay, now of course, we're just considering here angles theta that are from 0 up to 360 degrees or angles theta from 0 up to 2 pi. Now, in case that the angles are outside of those intervals, then we need to get first the angles that are coterminal with theta, okay, so that we can identify the quadrant where the angle belongs. Now, if the angles are measured between 90 and 180 degrees, the angle is said to be in the second quadrant. If the angles are measured between 180 to 270 degrees, then the angle is said to be in quadrant 3. And then if the angle is measured between 270 degrees up to 360 degrees, then the angle is in quadrant 4. Now, in the radian measurement, an angle measuring between pi over 2 and pi are in the second quadrant. Angles that are measured between pi and 3 pi over 2 are in the third quadrant. And angles measured between 3 pi over 2 up to 2 pi is in quadrant number 4. Now, next is the concept of the reference angles. So the reference angle is the acute angle formed with the positive or negative x-axis. So acute angles are angles that are measuring between 0 and 90 degrees. So what we meant here by acute angle formed with the positive or negative x-axis, is suppose that this is our Cartesian plane, this is the x-axis and this is the y-axis. And then let's say that we're going to rotate the angle, or we will measure the angle in the counterclockwise direction. So this means that this angle here is in the third quadrant. So the terminal side of this angle occurs in this ray, and the space or the angle formed between this terminal side and the x-axis would be the reference angle. Now, if the angle, let's say, is in quadrant 2, so this is our angle, then the angle formed by the terminal side with the x-axis is the reference angle. So this is actually illustrated in the following figure. So where theta is the original angle that we have and theta prime is the reference angle. So if the angle is in the first quadrant, the reference angle is also the original angle given. But in the second quadrant, if this is the angle theta, then the reference angle will be theta prime, which is the angle formed by the terminal side and the negative x-axis. And then for the fourth quadrant, if this is our angle theta, then the reference angle is the angle formed by the terminal side with the x-axis. So to find the reference angle in degree measurement, so suppose that the angle theta is from 0 degrees to 360 degrees, the reference angle of theta, denoted by theta prime, in the four quadrants are given as follows. So these are the formulas. In quadrant 1, the reference angle is the angle itself. For quadrant 2, the reference angle is computed using the formula 180 degrees minus the given angle. In quadrant number 3, the reference angle theta prime is the given angle minus 180 degrees. And in quadrant number 4, the reference angle is computed as 360 degrees minus the given angle. Now, in case that the angle theta is not inside this interval, then we need to get an angle that is coterminal with with theta. So to ensure that the angle will be inside 0 to 360 degrees. Okay, let's have an example. The theta equals 225 degrees. Let's find the reference angle. 225 degrees is between 180 and 270 degrees. So this must be in quadrant number 3. So the formula for theta prime or the reference angle would be the given angle minus 180 degrees. So that's going to be 45 degrees. Okay, number 2, theta equals 345 degrees. So this angle is between 270 and 360 degrees. So this angle must be in quadrant number 4. And the reference angle in quadrant 4 is computed using the formula 360 degrees minus the given angle theta. So this must be 15 degrees. Now, third example, 145 degrees is between 90 and 180 degrees. So this angle must be in quadrant number 2. In quadrant 2, the reference angle is computed using the formula 180 degrees minus the given angle 145 degrees. So this is going to be 35 degrees. And then fourth, we have 635 degrees. Now, 635 degrees is outside of the interval between 0 and 360 degrees. So this means that we need to get an angle coterminal with 635 degrees. So we can actually subtract 360 degrees here. So 635 minus 360 degrees is 275 degrees. Now, 275 degrees is an angle between 270 and 360 degrees. So that must be in quadrant number 4. So in quadrant 4, the reference angle is 360 degrees minus 275 degrees, which is equal to 85 degrees. Now, fifth, we have theta equals negative 315 degrees. So again, this is not inside the interval from 0 to 360. So we need to add something here. So we add 360 degrees. So adding 360 degrees, we will get 45 degrees. But 45 degrees is already in quadrant number 1, which means that the reference angle is the angle itself. Now for radian measurement, now we let theta be between 0 and 2 pi. So the reference angle of theta denoted by theta prime in the 4 quadrants are given as follows. So just like in the previous concept or reference angle in degree measurement, the reference angle is the angle theta itself. Quadrant number 2, the reference angle is computed using the formula pi minus theta. And then quadrant 3, the reference angle is computed using the given angle theta minus pi. And in quadrant number 4, the reference angle is computed as 2 pi minus the given angle theta. Okay, so for example, let's find the reference angles of the following. So theta equals 7 pi over 8. So 7 pi over 8, this is actually between pi over 2 and pi. So that's going to be in quadrant number 2. And the formula for the reference angle would be pi minus the given angle theta, which is 7 pi over 8. So in this case, combining these two, you will be getting 8 pi minus 7 pi over 8, which is pi over 8. Second, 4 pi over 3. So theta equals 4 pi over 3. This is an angle between pi and 3 pi over 2. So that's going to be in quadrant number 3. So theta prime or the reference angle is computed using the given angle theta, 4 pi over 3 minus pi. So combining these two, 4 pi over 3 minus 3 pi over 3. So that's going to be pi over 3. Third, theta equals 5 pi over 6. So this angle is also in quadrant number 2. It's between pi over 2 and pi. So the reference angle would be pi minus the given angle theta, which is 5 pi over 6. So combining these two, we will be getting 6 pi minus 5 pi over 6, which is pi over 6. And fourth, we have 25 pi over 4. Now, 25 over 4 is 6 point something, and that's going to be higher than 2. So, which means that this angle is not between 0 and 2 pi. So, that means we need to subtract 6 pi first from this angle to get an angle coterminal to 25 pi over 4. So, doing so, 25 pi over 4 minus 6 pi will be 25 pi minus 24 pi all over 4, which is pi over 4. Now, this is the angle that we have here, and that's going to be in quadrant number 1. And the reference angle is the angle itself. And then for the last example here, we have theta equals negative 14 pi over 3. So this is again outside of the interval from 0 to 2 pi. So if we compute negative 14 over 3, that's going to be negative 4 point something. So which means we need to add 6 pi in order to get the coterminal angle. So adding 6 pi, then we will be having negative 14 pi plus 3 times 6 pi is 18 pi. So the negative 14 pi plus 18 pi is 4 pi and then over 3. And this is actually the same thing as number 2. So which means that our reference angle is pi over 3. Okay, now, angles in which the terminal sides occur on either the x-axis or y-axis are called axis angles. In degree measurement, these axis angles are the angles 0 degrees, 90 degrees, 180 degrees, and 270 degrees, assuming that the angles are measured from 0 to 360 degrees. Now, in the radian measurement, now these angles are 0, pi over 2, and then pi and 3 pi over 2. Again, assuming that the angles are measured from 0 up to 2 pi. Now, angles that are special are actually measured at 30 degrees, 45 degrees, and 60 degrees. And in radians, these special angles are pi over 6, pi over 4, and pi over 3, respectively. Now, this last slide here shows us a table about the locations of the special angles among the quadrants. And then also, whenever the angles are outside quadrant 1, that this table shows the reference angles of those angles. So for example, if we have 150 degrees, 150 degrees is in quadrant 2. If we get the reference angle of 150 degrees, the reference angle is 30 degrees. And then the second table here also shows us the angles in the different quadrants having the following special angles. So I hope that you learned something about angles and their measurement through this video. And thank you for listening. And I hope that you can subscribe into my channel. Thank you.